the Michelin technical series of videos and presentations. At Michelin, our prime responsibility toward our customers is to meet their mobility requirements by providing them with safe, innovative products and services capable of satisfying their present and future expectations. Michelin is committed to safety when fitting radial truck tires using automated tire machines. This video will focus on some common bad habits made with automated tire machines and their associated consequences. We are confident that if you follow the best practices for the machine mounting mentioned in this video, they will assist you with proper tire fitment, but more importantly, provide a safe working environment for you and your employees. Truck tire mounting and demounting with conventional hand tools can be a very strenuous process. There are a variety of manual tire tools on the market that help simplify the effort. However, even with the right tools, it still requires a significant amount of physical strength and endurance. Automated tire machines are designed to reduce physical fatigue and make it possible for anyone to mount or demount today's radial truck tires. Whether you use an automated tire machine or manual tools, damage to the bead area of a radial truck tire will lead to premature failure. Because of the almost limitless power of the automated tire machine, they sometimes cause more damage than manual techniques. We will now look at some of the secondary effects of bead damage and factors that increase the probability of bead damage. Bead damage caused during mounting and demounting can be especially troublesome due to the delay that can occur before the tire actually fails. First, let's examine two different tire failure modes which originate from bead damage. The first and most common is air infiltration. This occurs when the inner liner is cut either by bead damage, penetrations, impacts, or bad repairs on tubeless tires. Air can migrate into any inner liner cut or penetration and travel through the casing from the inside out. Since the pressure in most truck tires is 5.5 bar or higher, there is enough energy in the air to separate the bond between the rubber and the steel of the tire. This separation will continue to grow from its point of origin and can migrate in the radial and/or circumferential direction. It usually appears as a bubble in the sidewall or bead area. In most cases, they are not discovered until the tire blows out. This air migration can be slow, taking several weeks before the tire actually fails. The mechanics of this failure mode are the same regardless of the entry point, but bead damage from poor fitting is one of the most common elements which lead to air infiltration in radial truck tires. The second type of failure that occurs as a result of bead damage is oxidation, caused by moisture migration. Like air infiltration, the moisture inside the tire is pushed through the casing due to the high pressure found in radial truck tires. This condition provides little warning before causing rapid air loss. The source of the moisture has many possibilities. It can come from poor storage conditions, high humidity, water entrained in the inflation air, and excessively diluted lubricants trapped inside during the mounting process. As with air infiltration, the moisture needs an entry point to travel through the casing. Bead damages caused during fitment can provide the entry point for the moisture migration. Since the cables of a radial truck tire are made of steel, the moisture will travel along the cables, quickly rusting them, causing a loss of tensile strength. Eventually, they will not have sufficient strength to contain the air pressure and carry the load. They will then rupture, causing a rapid air loss. The bead is most commonly damaged from poor techniques and lack of lubrication. However, sometimes even the most experienced tire fitter can break a bead during mounting or demounting. Let's visit two situations where this is evident. The first is a bead that has been exposed to brake heat. The rubber hardens and becomes brittle, making it easier to damage the bead even if proper techniques are practiced. The shape of the bead can also change due to heat and excessive load. Automated tire machines can easily break the weakened rubber, which will later cause air infiltration or moisture migration. The second situation involves smaller seat tires, such as 17.5-inch or 19.5-inch, and smaller aspect ratios, such as 7D series. These can present additional machine mounting challenges. Their sidewalls tend to be shorter and stiffer, which can be more difficult to install the second bead over the rim flange without damaging. These sizes may require a combination of machine mounting and manual mounting methods. The biggest factor causing bead damage when mounting and demounting with a machine is lack of proper lubricant. The lubricant needs to be applied correctly and be the right type and consistency. We strongly recommend using Michelin Tiger Grease 80 for both manual and automated tire machines. Tiger Grease is a vegetable-based product which provides superior lubrication and corrosion resistance. Remember, never use lubricant that contains petroleum or petroleum distillates. Check with your Michelin representative for availability of Tiger Grease 80. As with the manual process, ensure the tire is fully deflated. The technician starts by positioning the tire assembly on the machine with the short side of the drop center facing out. On most machines, the technician has the ability to raise and lower the wheel assembly and position the demounting disc. Ideally, he should place the demounting disc adjacent to the rim flange as close as possible. This will maximize the ability to break down the bead without overstretching the sidewall rubber, which could cause damage. On rusty wheels or wheels which have been in service for a long time, the technician should exercise caution when applying inward pressure with the demounting disc. The demounting disc must be repositioned and the unseating process must be repeated on the opposite side of the wheel. Once the inner bead has been unseated, the lubricant can now be applied to the tire and wheel. The tire is now prepared to be pushed off the wheel from the back side. When proper lubrication is used and the demounting disc is positioned correctly, the tire can be pushed easily off the wheel. It should not require manual effort from the technician. But as you can see, bad habits are not just found with manual mounting processes. This technician is risking personal injury by kicking the tire assembly in an attempt to speed up the process. The lack of lubrication almost always leads to bead damage. Because the rubber does not slide easily when dry, excessive force must be applied by the demounting disc. This causes distortion of the sidewall and creates a pinch point between the rim flange and the outer bead. The result is a tear at the bead toe. Another type of bead damage during the dismount process concerns cutting of the inner liner due to improper use of the machine. This happens when the demounting disc is positioned too close to clear the rim flange of the wheel. As the machine attempts to push the second bead off, it traps the bead between the demounting disc and rim flange. As pressure is applied by the demounting disc, the edge of the rim flange acts like a knife to cut the inner lining. This type of damage is not repairable and renders the tire scrap. If this damage went unnoticed and the tire was remounted, the cut inner liner will allow moisture and air to pass through the casing and result in air infiltration or oxidation of the casing cables. Additionally, the middle of the second bead sole was also cut during the same step due to the bead being trapped between the disc and rim flange. In this case, the rim flange is cutting into the rubber of the bead sole. Further damage can occur to the bead toe if the technician moves the demounting disc outward while pressure is being applied. The edge of the demounting disc and the edge of the rim flange can create a shearing action and cut the bead toe. Further issues are created when technicians use automated tire machines for purposes they are not engineered for. We are confident this machine manufacturer did not intend it to be a tool to clean rusty wheels. Additionally, the machine is not designed for and should not be used to straighten bent wheels. A smooth ride, long tire life, and even wear are dependent on good mounting practices. Besides possible bead damage, lack of lubricant and poor techniques can also lead to uneven seating of the tire bead. This condition is known as mismount and results in radial and/or lateral runout of the tire and wheel assembly. Radial runout is the visible up and down movement of the tire and wheel assembly. Lateral runout is the visible side-to-side movement of the tire and wheel assembly. Both of these conditions can lead to irregular tire wear and poor ride quality. To minimize the susceptibility of bead damage and mismount, we strongly recommend using proper lubricant and following inflation procedures recommended in the Michelin tubeless and tube-type mounting safety video series. Ask your Michelin representative for these videos. An automated tire machine can greatly simplify the mounting process and when used correctly will reduce the ergonomic effort required by the technician. With the short side of the drop center facing out, the technician will place the first bead in the drop center at the 12 o'clock position. The tire and wheel can now be lifted into place. Depending on his preference, the technician can now position the mounting arm or the mounting disc to mount the first bead. With a small rotation of the wheel, the first bead slides over the rim flange effortlessly. The rim clamp is then placed on the rim flange. This clamp has two purposes. The first is to prevent the tire from rotating with the wheel, and the second is to guide the second bead of the tire into the drop center. When the tire is fully mounted, the rim clamp can now be removed. The mounting process with the machine looks easy in the hands of a well-trained technician, but many bad habits are developed from lack of training and patience. This technician has developed his own method for putting on the first bead without the mounting arm. This is clearly not how the machine is designed to be used. These two technicians have decided to mount the tire without the use of lubricant. As they attempt to mount the second bead, the tire gets stuck. Watch and listen as the technician manually pries the bead over the rim flange. It is very likely that bead damage has occurred. Most of the bead damages during the mounting process can be attributed to 4 common bad habits. They are: lack of lubrication, mounting arms or disc not positioned properly, not properly utilizing the drop center of the wheel, excessive distortion of the bead during mounting. Bad habits can not only cause bead damage, but possible machine damage as well. In our first example, the technician has not lubricated the tire bead. Even without lubricant, the machine is strong enough to easily mount the first bead. When he attempts to mount the second bead, the lack of lubricant creates excessive friction between the rubber bead, wheel, and mounting arm. Furthermore, in all the examples given, the bead must be allowed to slide into the drop center area of the wheel or bead damage will always result. He further complicates the process by positioning the mounting arm too far away from the rim flange. Notice when the technician extracts the mounting arm, it becomes hooked on the bead toe. However, it does not slow the machine down, and the arm is pulled out of the tire. Now, let's dismount the tire and examine for potential damage. We will focus on the area where the mounting arm hooked the bead toe. As you can see, the damage caused seems relatively minor and might go unnoticed by the technician, but if this tire was allowed to run, the damage would be severe enough to create air and/or moisture migration through the casing. Now, let's examine the bead distortion issue mentioned a few moments ago, created when the mounting arm is too far from the wheel. When the technician attempts to mount the second bead over the rim flange, extreme tension is placed on the rubber in the bead area. The force is so great that it actually trips the electric motor powering the tire machine. As the technician continues to attempt mounting, there are 3 trouble spots to point out. The excessive stretching will cause small tears in the bead sole. Excessive tension in the area of the bead clamp will create damage to the bead toe. The tire is not moving into the drop center, which will prevent the completion of the mount. Let's take a closer look at the damage caused by the improper techniques. In trouble spot number 1, excessive stretching has created micro tears in the bead sole, which will lead to air infiltration. The condition shown in trouble spot number 2 normally cuts the pointed bead toe, generally removing rubber only. This type of damage can usually be repaired. However, if steel cables are exposed, the tire should be scrapped. In trouble spot number 3, we can clearly see the bead is experiencing extreme deformation. This could result in a bead rupture, or the bead could slip off the rim during the inflation process. The final example demonstrates just how critical it is for the bead to slide into the drop center. Sensing there is too much tension on the bead, the technician adjusts the mounting arm to relax the bead. Since the bead 180 degrees away has not fully engaged in the drop center, the adjustment does little to improve the situation. Now the mounting arm and rim flange are close together, acting like a shear to cut off a large piece of the bead. This tire is destroyed. This concludes our presentation on automated tire machines and the tire damage caused when used incorrectly. We recommend you watch the other installments which make up the Michelin tire mounting video safety series. We hope these videos allow you to work smarter and safer. Thanks for watching.
Michelin, a better way forward.